But there are other things that did change.
Yeah, there was I think the first major rewrite of the server happened between version 6 and 7. And I think the main theme was encapsulation, trying to encapsulate all the different libraries. We have to manage, I mean, today you get all that in a framework, like you use .NET or Java or whatever, it all comes with the library. But we have to write our own hash maps, array managers, pool, memory managers, tree, all the tree operations, all that, and each one of those components was like a little library, and the major thing that we did from 6 to 7 on that front was to encapsulate. It was all written in language C, and C is, I think, is notorious for being
there was a big debate, right, when we're doing the 7, whether we're going to go pure C++ or stick with C.
Stick with C,
right? And because we want the object oriented.
Yeah.
There was a big thing. We want to do C++ or not. But what we end up with is that it is object oriented, but basically we invented our own object stuff using C. And so it was written.
There is actually a book. I still have the book in my house. A guy that described how to use C in a safe way by encapsulating the library and all that. So we followed that recipe, and that was kind of the major rewrite of the engine using that recipe, like to hide for 7 to hide all the implementation behind the the C files.
I think the big thing in 6 was the network and the client server.
Yeah, all the networking, all the bug fixing.
We have all the bug fixing. We have to support all the
rules and feeders started in 6.
The rule feeders, and in terms of connections, we have to support all the different protocols. That's all done in 6. But it's a single threaded.
Yeah.
Okay, it's just one server.
Guys, can we have a bit of a timeline though, because we've got version 1.0 here. So my understanding is Manny started in 1983, and then programming it, and then he released it in 86. So when did the rules and feeders come in?
That was between 5 and 6. That was 95.
That's before me. So I mean, I only heard the stories. So I talked to him about that. Because the rule itself, there are 2 major patents from TM1. The first one is about the storage of the data. It's the tree of trees, so the database of the tree of trees. The second one is the rules. The rules basically is link all the cube together. You can specify any cell in terms of another cell. That's the rules. So I don't know exactly when that went into patent, but it's implemented before they have feeders. So just the rules. But I don't know exactly
that happened when I joined in January of 95. Manny was working on the rules and feeders. I don't know exactly when feeders started to emerge from but it was in 95 definitely. It was before the release of version 6.
Yeah. So we kind of all joined around 95, 96. That's when the industry in that the OLAP stuff started picking up. But so the rules is kind of done. I mean, I guess when we joined, he's still working on it.
Yeah. So version 6 is mostly about rules, about networking, about server. Some of the Unix. I think actually 6 came out in Unix.
Yeah, the first version of Unix is actually on 6.
On 6, yeah. And then 7 is it was like a major rewrite of all the libraries, the multi-threading,
multi-threading
Stargate
was a big thing. Right?
Server, I think the Stargate. I mean, Stargate itself, had like 6-7 evolutions. The first one was actually done in 6. The first version is actually done in 6, but then there has a lot of at least 5 different revisions.
Explain Stargate to us and why it's important.
Well,
Yeah, how did it come about?
well, Stargate. Roger, you want to explain?
Who
You
came
want
up with
me?
that name?
It's like
Probably
a-
you.
Who came up with the name?
No, it wasn't me.
Okay, name we don't know who came up with.
I think it was Jay. I think it was
could be
Jay.
The fundamental concept is the following: the TM1, you store all the data. Usually, when you want to get values, you just go to this cube, and looking for one cell at a time. So imagine that you have a big, hotel with many rooms. Every time you need a value, you go to the right floor, find the room, get a value, and then you need another one, you go to the same place. And so that's, when you need a lot of the values, that's adjacent, and this is just not efficient. So Stargate basically saying, okay, I need to get a consolidation on those values. So I'm going to make one trip and connect all of them and build into another small, essentially consolidated cube. And when I need a value, I just go to that cube, and instead of go to the main cube. So
It's a cache. It's a cache.
Yes.
it's a cache, but it's fundamentally you're saving the consolidation time instead of adding one at a time. You're going along the way and they collect them and put it into your a new cube, or fill up your new cube.
Yeah, right.
So this is the basic principle. I think
The thing to understand about TM1 is that when, at least in those days, I don't know today how it works, but those days when you fire that server up, there's nothing in memory. It's blank, and
It's
as you
still
start
is.
using it, it starts loading and loading and loading and loading, and
It didn't even load the initial data of the
it
cube?
loads
It does.
dimensions and but
Right.
the cubes are kind of
I know the cubes.
Well, the cube
But,
loads the data of the cube, right?
It does not.
It doesn't
The
calculate.
it doesn't calculate anything. It's
There are
just,
two
it's
things
just,
that you
that
do
it's
not
just
calculate.
loads the logs and the dimensions, but
on the data, on the raw
You
data.
know that the raw data
Yeah, that's
and
the
the
log
actual feeders. The
No,
thing
no,
you do not do
the
is
cube
that,
saves data on disk, right? And then it loads that data.
yeah.
but there is no consolidation happening.
No consolidation,
okay, no consolidation,
and
no
no rule
calculation.
calculate values.
No, right.
Okay.
Yeah, it's just the leaves, the leaves
Right.
of
The
the
leaf
cubes
values, yes.
and the dimensions.
Yeah.
Yes.
Yeah. So
Yeah.
that's
The NIF cells and
which is basically
the
it's
dimension
just a
structure.
projection of the log file.
So if you have no data, you can have like a gigantic Hilbert space, and it's really not taking your time, right? Because
Yeah,
all you
that's-
have is just
This
you
is
have
the
one
secret
cell.
of TM1, right? It's this is part of the simplicity or the elegance of it, right? It's
But-
just
but
the
I think
idea of
what
doing
the-
it that way, right?
I think what Raja alluded to is that as the time goes by, when people are making requests, you start to calculate.
Yeah.
Calculation involved maybe rules, involve consolidations. Okay, so consolidations, because when you wanted to look up consolidations, instead of keep going back and forth, it would be better to kind of like know you're going to need this set of data. We're going to consolidate together, and when next time you need it, we're just going to go to that smaller cube that's already consolidated for you.
Yeah. So the way it manifests itself in the engine is just it's created a smaller cube of that data kind of thing.
Yes,
Yeah.
it's essentially a
In a way.
small cube.
Yeah, right.
Yeah.
and it's just big
There are
segments.
two
of-
differences. One is a smaller cube, and two is that it got already involved consolidation.
Uh-huh.
If
right.
there's no consolidation on the titles, there's no point to do anything.
Yeah, right.
Okay, so yeah.
You mentioned earlier like that when Manny was like kind of mentoring you guys that he would kind of talk about principles, like or like when you talk about principles, are those like principles of programming? Was that just like principles of the business problem you're trying to solve?
Well, I know all kind of those. I remember one of the things he always said is don't do a linear search.
Don't do a linear
Don't
search.
do a linear search.
Yeah.
Never do a linear
Well,
search.
that's
Okay,
that's
well,
ingrained
that's a
in
rule,
our
it sounds
head,
like
right?
to me.
What do you mean? Some sort of while loop to go and look through a list of stuff?
Right. If you're gonna look for something, put it in a hash or something. Don't just go through the whole thing, because even if it's very small.
It's time. You're using up time.
Well, no. Even if it's very small, that small loop may end up in a big loop, and then now you got a big problem. So
Yeah, right.
Well,
do it
that was
properly right from the beginning.
one of his principles. The other one was keep it simple. simplify the hell out of it, and it doesn't matter how complicated it may look. Try to simplify it and make it.
That's for our work itself. But generally, TM1 there's a guiding principle that everything you need to looking for data is data driven. Okay,
Well,
you never go through your possible spaces. Okay, so you could have a 1,000 by 1,000 by 1,000 by 1,000 dimension.
Yeah.
You have one cell. Whenever you're doing calculations, it's always driven by that data. So there's only one cell involved. Mm-hmm. Okay, so if you decide to go, I'm gonna look at how many tuples I have, it's never gonna come home.
Always start from the seed,
Always start with the data. So that's the key of the sparse handling.
Yeah, that's right.
So what's the opposite of that? The opposite is to create the space for the data and consider that as as your.
Well,
your
you can
room rather than just
imagine,
consider
right?
the
So
data
let's
itself as a
say I
starting
have a
point, or what?
two-dimensional space, just 1,000 elements by 1,000 elements.
Yep.
You put one value in there.
Yep.
If you want to know what's the total, you decide to go to, I'm going to just find out every single cell.
Yeah.
Okay, I got a 0 here, 0
You have
here,
to
0 here.
scan the space.
You scan the whole space, you get one value.
And there's a lot of technology that still works that way today, like competitive software. It's
I'll give you
unbelievable.
an example. I fixed a few years ago when we were working in Cuban services. They were calculating the multiplication of two cubes. Mm-hmm. So this cube times this, or this slice of the data times this slice of the data.
Yeah.
Create another one. And what they were doing is they were doing through all the tuples. This one times this one times this one times this one times. And that was taking, the customer was complaining.
Multiplications.
In TM1, they often
client,
never finish.
Yeah, the client was complaining that was taking like an hour and a half or something.
Yeah, right.
And I just changed it and said, okay, you don't do that. You just look at the two data points that you have, go through the data points, and if you take a look, if they're the same tuple, you multiply those, and you just go through the data points. Mm-hmm. And then it went from an hour and a half to 10 seconds. Seconds.
Yeah, right.
Yeah. So
why is that? So it was so easy for you to see that. Was that because of the way? Do you think it's the way you thought about it? Because the way they taught you? Or?
I already knew that. I already knew you cannot do. Whenever you're gonna loop through the sets or the tuples of a set, you're gonna be waiting until the sun burns out.
You traverse the tree. Everything is internally, structurally, is just a tree of trees.
Yeah.
It's one tree that spans another tree and another tree and another. And I guess it becomes like muscle memory to traverse those trees.
To us, it's a second nature.
Yeah,
right?
so you like everything you write is just traversing trees, up and down, left and right.
Yeah.
But I guess for other people who might be designing databases or queries, engines or whatever, it doesn't make sense.
Well, I'm sure
they wouldn't
there are
even think
other.
of that for some reason.
I'm sure there are other databases that do the same thing too.
No, it's not a new thing. Relational databases. Mm-hmm. From the 60s and 70s, they use indexes, B trees, and all that. So that's
I think it's particularly important for multidimensional database because you can very quickly explode.
Yeah.
Okay. And if you're asking, multiply together, especially you also have consolidated values in the middle. You multiply together, it's just quickly get out of the hands. And people who don't have experience on these parts, they don't understand that you don't ever ask those questions.
Yeah.
Okay, you ask those questions, you are in the dead end.
Right.
You always start with data, and because data is sparse, your computations always need to be to the actual data. Mm-hmm. Yeah. So that's important.
Which seems like so obvious and simple when you hear people like you guys describe that, but I guess it's not quite that.
Well, the implementation is not always trivial.
Yeah, I imagine. Yeah. Otherwise, there'd probably be a lot more.
But I think we all work in those areas. We talk about traversing the tree. I think Manny started with the tree. I think Roger had a contribution doing the two tree traversing, for the going through the component and the data tree. Mm-hmm. And I think Jose actually had a hand in the three tree traversing. To allow the scenario to be
it becomes
out.
A generalization of N3 traversal, basically.
Yeah. Well,
everything's done that way.
N3 intersection, basically.
Intersection, basically.
Yeah.
So
Right.
Once you find the pattern to go down on multiple trees, and at the same time doing all the consolidations, then it becomes kind of a.
Yeah, I think that in team one that we definitely have got that done, handling sparsity. Yeah. Okay, that's like a really important. When you talk about the people have sparsity, but have like really be able to scale. That take a discipline, and I think a benefit for you just have a few good hands. You have a lot of people go stir. They're going to everybody gonna start to do things differently. Yeah. So I think it's ingrained in our mind, and so they, so that's a good thing.
Were there other kinds of principles that you can remember from back then that kind of Manny embedded in what you guys did, or how you engaged with customers, or?
Well, Manny has this thing. I don't know if it's taught us as a principle, but we definitely learn. We see it in action. Mm-hmm. Manny is really good with when customer or partner come up with a problem, that he is able to abstract it and generalize it. So abstract it so that you can clearly articulate how we're going to implement this, how we're going to fit it into our overall scheme. Mm-hmm. Right? Everything you put in, I mean, you guys saw the video about the simplicity, that everything fit in the right place. Every something new, it needs to fit. So you may want to ask something, and he has to think about how is this going to fit into this thing, or maybe it does not belong here. Mm-hmm. So there's abstraction involved, and then there's a generalization that he wants to do this in such a way that all the customers and partners are going to benefit, not just for one user.
Yeah.
Okay, so
that's
there's a lot.
Easier said than done to be able to do that, huh?
You need to know how to ask the right questions.
You have
get
to
to the right questions first.
Right. You need to have an eye for the simplicity, and also how to sense of fit and how. Yeah, this is easy to see. You see it in action. We have seen problem come through, and we're all talking about how to implement it. We're all talking about how to do it, and he will come say how we're going to do it. Why is this important? And so that's we learn from that.
It really gets drilled into your brain when you get trained by someone like Manny, when things like that, take the problem, ask the right questions, understand it, then create the abstraction, understand it at a higher level, what it means, then generalize it and apply it across the table, right?
Yeah.
Uh-huh.
So when you repeat that a couple of times and you get someone like Manny teaching you how to do it.
Yeah, I got to see though.
It becomes second nature.
It's never teaching by lecturing.
Yeah,
right?
it's
like teaching is by practice.
Yeah. I mean, we made many mistakes. I mean, it was like try it and make a mistake and try again and again until you got it right. But after you repeat that a couple of times, then everything in life becomes the same exercise, right? Yeah. And in my career, I have applied that methodology everywhere. Like I see the problem, I look for the pattern. It's something you always search for the pattern, and then once you identify it, then you start creating a solution on top of it. Like layers and layers of.
As elegantly as possible.
Yeah, and it gets you to a simpler solution always because you always look. You try to elevate from and see the problem from the top, and then. So it was a really good training. I mean, it was.
It is.
I remember going to Manny many times with an idea, right? Manny, I'm going to do this, blah blah blah, and they would look at me and say, "Okay, let's go back. What are you trying to solve? What's the problem you're trying to solve? Go back to the beginning and explain the problem to me, and then I'll tell you if that idea is good or not."
Right.
So it would take you back there, and then you would have to, reason with him.
Yeah.
Why that was.
I see that
idea
in young developers is that usually when you don't have the training and that experience, you rush to the solution.
Yeah.
Kind of, oh yeah, I know that, and I have a solution, and you fix it, but you miss a lot of rushing to the solution creates a lot of gaps that you don't see at the moment. And then you have to struggle with the gaps, and the people call the technical debt and all that accumulates. So if you have the training, the proper training of hey, wait, understand this first, and of course you have to try the solution, and you will fail, but with time it becomes like a practice.